Revolved features are created by revolving geometry around an axis. The revolved geometry is created using the same tools and methods as extruded features. However, revolved features differ from an extruded boss or cut by using a circular extrusion path rather than using a linear path perpendicular to the sketch profile. Revolves require axisymmetric geometry and a line used as the axis in the sketch. Under the right circumstances, a sketch line may also be used as the center line. In this lesson, I will demonstrate how to create a piston head component using the revolve feature, and then I will create a cut going around the outer face of the piston. Each of these will be created by revolving a single sketch around an axis, creating individual features for the part. To begin creating the piston head, I'll click the New icon, and I'll select Part MMGS as my template and click OK. I must first create a sketch in order to create the revolve feature, and so I will right-click the front plane from the feature tree and click Sketch. The sketch profile will be created using a series of lines. I'll enable the Line tool, and I'll begin by drawing a vertical line starting at the origin. This will serve as the axis of revolution for the revolve feature. I'll continue sketch lines to create the outer profile of the piston head. Before I begin adding dimensions to the sketch, I want to be sure that I can dimension the piston according to its diameter value rather than the radius. To do this, I'll change this vertical sketch line on the left to a construction line. I'll click on the line, then select Construction Geometry from the Context toolbar. Even though this construction line changes the sketch profile from closed loop to open, the profile can still be revolved using the construction line as the axis of revolution. In many cases, the revolved profile won't be attached to this construction line, which can create a custom-shaped hole going through the middle of the revolve feature. Now, I'll add a few dimensions to fully define the sketch. First, I'll add the dimension that defines the piston head's diameter value. I'll enable the Smart Dimension tool. Then select the center line and the blue line on the right. Now, when I hover the cursor above the sketch, you can see a regular dimension appears between these two lines. However, if I move the cursor to the left, on the other side of the center line, it switches to the diameter value. SOLIDWORKS automatically recognizes that this dimension can be used to create a diameter value. I'll place the dimension here and give it a value of 150 millimeters. I'll add a couple more sketch relations and dimensions to finish defining the sketch. The small segments at the end should be equal, so that the wall thickness of the piston is constant. I'll dimension one of these segments to be 20 millimeters. And I'll dimension the total height of the piston to be 125 millimeters. Now my sketch is fully defined, and I can create the revolve feature using the sketch. The revolve feature can either be found under the Insert, Boss Base menu, or I can activate it by clicking on the Features tab of the Command Manager and selecting Revolved Boss Base. When I click on it, SOLIDWORKS prompts me that this sketch is currently open. This is because I changed the short vertical line on the left to be construction geometry. To create non-thin revolved geometry, the sketch will need to be closed, so I'll click Yes to automatically close the sketch. In the Revolve Property Manager, the construction line is automatically selected as the axis of rotation. Also, because the sketch profile was closed when I clicked Yes, the preview of the revolve is automatically generated. If there were other contours I wanted to include in the revolve, I could continue selecting them. I only have one sketch profile, so I'll move on to the options for Direction 1. Here I can specify a number of end conditions that define the geometry. To create a fully revolved feature, I'll set this end condition to blind and set the angle value to 360 degrees. Now when I click the green check, the revolve is created. Now the piston head can have a cut created along the outer face of the piston. However, before I move on to the next video to create the cut, I want to verify that the piston head is 150 millimeters in diameter. To do this, I'll use the Measure tool. which is found under the Evaluate tab of the Command Manager. I'll click on Measure, then select the outer cylindrical face on the piston, and I can see the diameter value I expected. With the piston head created, I can now use the Revolve feature again to create a cutout around the outer face. The cut will have a rectangular profile and will be revolved 360 degrees. To begin creating the rim, I will begin a new sketch on the front plane. Switch to a Normal to view and enable the Center Rectangle tool from the Command Manager. Now I can click the center point location for the profile, which I will place along the silhouette edge of the piston head. By doing this, I'm adding a sketch relation where the center point of the sketch will always remain on the silhouette edge, making the model more robust in case the shape of this piston head changes in the future. Now I'll place the corner of the rectangle. At this point, I want to highlight the fact that the rectangle extends past the silhouette edge. This is best practice when creating Revolve features, which forces the Revolve to always extend through the entire side of the model as it's revolved. Now I'll use the Smart Dimension tool to set the height of the profile to 15 millimeters. The distance from the top of the piston head to 25 millimeters. And dimension the rectangle to be 5 millimeters on either side of the silhouette edge. Now I want to make sure that I have the center line I need to revolve this profile. The center line won't be attached to the profile itself, since I want the rectangular cut to revolve about the center of the piston head. Because I want these to revolve around the same center line, I'll use the original sketch's center line to define the second Revolve feature. This means that this sketch is complete, so I'll exit the sketch. Now I'll enable Revolved Cut from the Command Manager, and SOLIDWORKS prompts me to select a sketch to revolve. I'll expand the Feature Manager design tree and select the sketch I just created. This selected the rectangle as the profile to revolve, but the axis of revolution selection box is still blank. I want to use the construction line from the first sketch profile, which will make sure that both Revolve features will always share the same axis of revolution. To do this, I'll expand the Revolve 1 feature in the Feature Manager design tree, and right-click on the sketch and select Show. Now I can select the sketch line at the center, and the preview appears. The rectangular profile is cutting around the center of the piston head. I'll leave the Direction 1 options to Blind and 360 degrees. And when I click the green check, the cut is created. I'll hide the first sketch in the graphics area. Even though the piston head is complete, I want to demonstrate how the revolved cut will still cut around the edge of the piston head if its size changes. I'll go ahead and edit the sketch of the first Revolve feature. Change the diameter to 165 millimeters. And when I exit the sketch, the cut is maintained. This is because I make the rectangular profile coincident with the piston head's silhouette edge, and I oversize the profile so that it always extends past the silhouette edge.